All right, let's tackle one of the biggest questions in tech, one that honestly stops a lot of people before they even get started. Do you really need to be some kind of math genius to be a great coder? Let's dig in and find out.
A lot of people have this image of a coder just hammering away at a keyboard, lines of code flying across the screen. But here's a question. If you're just typing, are you really programming?
So this leads to a super common belief that you don't need to be a math person to code. And you know what? For the really basic stuff, like the very tip of the iceberg, that might even feel true. But what you're not seeing is the massive logical foundation holding everything up underneath. Let's think about it this way. Knowing coding syntax is kind of like knowing a handful of words in another language. It's a start, for sure, but it's not enough. Logic, which is really the heart of math, that's the grammar. It's what lets you take those words and build a powerful argument, or in our case, a powerful and working program.
So that brings us to our first major point. If you want to build anything meaningful, you've got to go way beyond just knowing the words.
This really gets to the core of it all. At its heart, coding isn't about writing lines of text. It's a tool for solving puzzles. It's the art of taking an idea and giving it a logical structure so that a computer can actually bring it to life.
And here's why that matters. Without that solid foundation in logical thinking, you're gonna hit a wall. Yeah, you can probably write code that works, but you'll get stuck. You'll only be able to build simple things, and you'll never quite figure out how to create something that's truly efficient, innovative, or complex.
Which brings us to the main idea here. We really need to stop thinking about math as just calculations and start seeing it for what it truly is. It's applied logic.
Right at the heart of every single program are algorithms. And what's an algorithm? Well, it's really just a recipe, a set of logical, repeatable steps to solve a problem. That structured thinking is mathematical thinking.
I absolutely love this concept from our source material. Math is so fundamental. It's like a universal language that can lay out the rules for any world, including the virtual ones we build from nothing with code. It provides the framework, the physics, the very logic for those worlds to even exist.
And this quote just hits the nail on the head. The skills you build when you study math, like analytical thinking, spotting patterns, and applying rigorous logic, are the exact same skills you need to be a great programmer. It literally trains your brain to think the way a computer needs you to.
Okay, so this all sounds good in theory, right? But where does this actually show up in the real world? Let's check out some solid examples of where this mathematical logic is absolutely essential.
You might not even realize it, but from the second you pick up your phone in the morning, you're interacting with systems that are built on a powerful mathematical engine. Let's start with something fun, game development. How does a character move through a 3D world? That's vector math. How are those amazing 3D graphics created and rotated on your 2D screen? That's all linear algebra. And how does the game camera always know the perfect angle? You guessed it, trigonometry. Modern gaming just wouldn't exist without math, period. Now let's talk about one of the hottest fields out there, AI and machine learning. How does an AI learn from massive amounts of data? Through probability and statistics. What's the hidden structure behind those powerful neural networks? It's linear algebra. And how do you optimize those models to make them faster and more accurate? That takes calculus. It's math all the way down. Heck, even your social media feed is a mathematical masterpiece. Graph theory is what maps your social network to suggest new friends. Simple weighted averages are what rank the posts in your feed. And all your user data gets processed using, you guessed it, linear algebra to power those recommendation engines that keep us all scrolling. Okay, I get it. That all might sound a little intimidating. So let's get practical for a second. What level of math do you actually need to get started and be successful? So let me be perfectly clear about this. The idea that you have to be some kind of math prodigy to be a coder is a total myth. You do not need to be solving complex theorems in your sleep. Here's the bottom line. For a huge number of programming jobs, we're talking about building websites, creating mobile apps, you don't need advanced calculus. What you do need is that logical, problem-solving mindset that, well, math helps you build. This table breaks it down really nicely. Look, every single programmer needs a solid foundation in problem-solving and logic. That's the baseline. For web and app development, it's primarily about that logical thinking. But for those more specialized fields like game development or AI, you're going to need to dive deeper into things like linear algebra and statistics.
So let's try to reframe this whole thing. Math isn't some big, scary gatekeeper trying to keep you out of coding. Not at all. It's a key. It's the tool that unlocks the doors to more advanced, more creative, and way more powerful programming.
Look, anyone can learn to write code that just works. That's step one. But embracing that mathematical and logical thinking, that's what gets you to step two. Writing code that is elegant, super efficient, and capable of solving the hardest problems in totally new ways.
So, I'll just leave you with this question to think about. Is this logical foundation, this mathematical way of thinking, the secret power that you've been missing to take your own skills to the next level?